Hello, good morning. So this is problem number 9, which is similar to the lenses problem that we were doing. So it says an object of height 3.5 centimeters is placed 26.1 centimeter in front of a spherical mirror. So we have a mirror over here, and a object is placed at a distance of 26.1 centimeter. The height of the object is 3.5 centimeter. Suppose it is desirable to produce a virtual image that is upright and 1.9 centimeter tall, right? So first thing is that the image is going to be virtual and it's going to be upright. So, and it's 1.9 centimeters tall, right? The first part says, should a concave or a convex mirror be used? All right, so the answer for this one should be that the mirror used would be convex. And the reason for that is because the image is upright, right? It's not inverted. That's the first reason. And the other reason is that it's, as you can see, the height is 3.5 initially, right? And now it's reduced to 1.9. So it's upright and diminished or smaller now, right? So the answer for this one, it should have to be a convex mirror because the image is upright and diminished. Okay, let's try to solve the part B. Where is the image located? So you need to find the image location. The image height is already known, which is 1.9, and the object height is also known. The distance is also known, right? So when two heights are known and a single distance is known, we are going to use the magnification formula in order to calculate the image location. So my magnification formula is m is equals to height of image divided by the height of the object is equals to minus distance of the image divided by distance of the object, right? So the height of the image given in this question is 1.9, whereas the height of the object given in this question is what? It's 3.5. Negative, the image distance is what I need to figure out, and the object distance is basically in front of the spherical mirror 26.1, so I'm going to use just negative 26.1. Right, so now let's try to calculate this value, which is 1.9 divided by 3.5 times 26.1. So I'm getting an answer of image location as V is equals to 14.16857 centimeter, right? I've written it complete so you can use your basic significant figures that are required in the question, right? So it's 14.16857 centimeters right now over here. Just gonna place it over here and make some space. All right, so that was the image location, 14.168, 14 point, and that's a centimeters. Part C, what is the focal length of the mirror, right? So for focal length, you right now you know the image distance, object distance, right? So focal length is very straightforward with the same formula that we know. So for focal length, it would be 1 over the image distance plus 1 over the object distance, and that should be equal to 1 over the focal length, right? So for image distance, it turns out to be that we have the answer from the previous part, which is 14.16857 plus object distance. We already know it's a negative 26.1, and focal length is just 1 over f. So I'm going to solve this equation to find the value of focal length. All right, so I'm getting an answer of focal length over here, which is 30.9937 centimeters, right? So this is the value of my focal length. You could probably write 40.0. Just make sure you apply the same sig fig that is required by the examiner. Yep, so that is going to be my answer for the part C over there. Okay, so now that this is the last part, which is the part D. What is the radius of curvature of the spherical mirror? All right, so there's a formula which you need to know for the radius of curvature for a spherical mirror. I'm not sure if it was there in your notes, but probably the instructor would have gone through it. The formula is very straightforward. It is that radius of curvature of mirror is equals to twice of the focal length, right? So R is basically equals to 2F, which means it's twice the focal length. Radius is equals to twice of the answer of focal length we already get in part C, that's 30.9937. So radius of curvature turns out to be 61.987. All right, so radius of curvature turns out to be 61.987 centimeters. So use that as appropriate for your answer for the part D. That's all for question number 9. It is about some of the basic information we're given. You need to find the type of mirror, image of the location, focal length, and the radius of curvature for the mirror. That's all.